Hey, good morning. To the best of my knowledge, it's Wednesday, the 18th, and this is our only class meeting on week 2. And the recording is on. So before we get into the material that I want to cover, we always have the opportunity, well, anytime, particularly at the beginning of the class, to pick up leftover questions. Things that after class last time you looked at and it was kind of like, So let's start with that. Anybody have any leftover questions they want to throw out there? And this usually meets with very poor results. Okay. If some of those questions pop into your head during the class, just bring them up. After the class and you don't want to wait till the next class, just send me an email. As we get into programming, some of those questions will involve code. And the same thing applies. You can ask them in class, you can send me an email, but it's a lot easier for me to have a discussion about code if I see your code. Do not, please send me screenshots of code. It's just about useless. So you can do one of two things or three things. You can cut and paste code right into an email message. You can attach your PY file to an email message, but Outlook doesn't allow you to open it because it thinks you're trying to do something sneaky. So if you attach a PY file, then I have to forward the message to my private email. Or you can zip the file and attach the zipped version of it. That works. Or you can cut the paste the file into like a notepad document or anything else and attach that. This is not true when you submit your code to D2L. When you submit your code to D2L, you're going to be submitting your PY file, or in some of the more complicated, well, actually not. In some of the exercises, even if they're not complicated, it will be PY files, plural. So we'll go over that. And usually once people have seen it, it's fine. Okay, couple of things that I want to go back to the Get Started section, just to make sure you're aware that they're here. Because last week, of course, we were getting into the swing of the class. I didn't want to read you through the things in this section because everybody presumably reads just fine on their own. So there are a couple of things that I thought of that you need to be aware of. 4 students in the class have not submitted the day 1 form in spite of my insistent nagging. So just to remind those 4, 1 is the day 1 form is sitting at the bottom of this section. And 2, after the last week's assignment, I won't grade any future assignments unless you send me an email, either with the form signed and scanned, or just a statement that I've read the form, I understand it, and I agree to follow it. So some way or other, I need you to acknowledge this before I go forward grading your work after the last assignment. It's probably time for me to stop writing nagging emails about this. So I'm going to assume that either of those 4 students are either listening or will listen to this video and will behave accordingly, because they'll notice that they won't have any grades for the class. Backing up here, let's back up to section 2. And no one asked, and of course I forgot, but there is a lot of blah, 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 blah in this section, which it's worth reading at least quickly. But there's also something important here, unfortunately, kind of buried at the bottom. And it's this, late work. Without this policy, there's always 1 or 2 students who decide that they can do the whole semester's work in the last 2 weeks or the last weekend. And somehow or other, I can look and grade all of those assignments within the few days still available to me to do that. Well, it doesn't work as a learning thing. It doesn't work for my schedule. So we've implemented across the department a late work policy. And that is this: 15-week courses. This is wrong. It's not 10%, it's 10 points. So you will lose 10 points per week on any assignment up to 3 weeks or 30%. 30 points. Unless I hear from you because of some extenuating circumstances, that's it. I don't want to hear from you about this assignment 4 weeks, 6 weeks, 2 months late. Also, we run into a barrier at the end of the course where you don't have 3 weeks. And in addition to that, all work must be submitted by the end of week 14, not the end of week 15. So you need to keep this in mind. And it's important to keep in mind, of course, that your 100% perfect work after 3 weeks late is now only 70%. So my advice, which I can already see people ignoring, is don't do your work and submit it right against the deadline. Start working on it as soon as you can. And if you're done, you're done. And if you need more time, you need more time. If you promise not to tell anybody unofficially, if it's a day late, I only deduct 5 points. So that's my own little accommodation to the fact that stuff happens. I assume there's any questions. I assume not. It's pretty straightforward. Just know that it exists and know that unless we've spoken during the semester, I'm not going to accept all of your semester's work in the last week or two. It's just not happening. All right. So unfortunately, that's kind of buried in here, along with a lot of other information. I guess while we're here, we could once more look at this to remind you that there are 3 projects in the class worth 40% of the grade. The assignments, there's 10 of them, I believe. Whatever the number is 40%. And the final project is worth 20%. I'll say it a couple of more times. Theoretically, you can pass the course without doing a final project. In my experience, it doesn't happen. That if you're not doing the final project, you don't have a good enough grade in the rest of your courses to come up with a passing grade. All right. So let's go back here. Let's look at another section. That's 02. Let's look at 06, which I don't think we did together. Maybe we did, but it's worth repeating. So I've had students in class evaluations at the end of the semester say, I was confused about where we were in the course. I didn't know what was due when or what module we were working on. Well, here, it doesn't say 15 weeks, but here's a schedule for our class. Broken down, we did look at this, I take it back. Broken down into 15 weeks, including the dates for those weeks. I remember now, we did look at it. In general, this is the module we're working on. These are the topics we're covering, and these are the assignments due with a due date. So you have those dates. And some other information like the last date to drop the course with 100% refund is passed. 50% refund you have this week to drop with a 50% refund. Now that's a drop. That's different than a withdrawal from the course, which is here. So up until April 6th, you can withdraw from the class and it will not appear on your transcript because there will be no grade. Therefore, it can't count as your GPA, towards your GPA. So sometime before that date, if you have done little or no work, that's the preferred option. If you've done enough work, and I don't mean to be sarcastic about it, it's the way it is. If you have done enough work to get an F, Now there's an interesting situation that I don't have the answer to. And the question is it better to get an F or a withdrawal? And the best answer I have is if you're on financial aid, talk to the financial aid office and get their opinion. Or talk to your faculty advisor and get their opinion. As a full-time instructor, I never got a good answer to that question. If your final grade is less than 50, you're not going to get an F, you're going to get a U. And that basically means you did not do a substantial amount of work for the class, and we will not even give you an F grade. So we may change this a little bit. I'm not going to leave all these boxes empty. We're going to fill things in with Zoom time during those last few weeks. And, there are times when we'll work a little bit ahead. There are times when we'll probably be a little behind, but it'll all come out well. So this week, we're talking about Module 1, but in the last class, we talked about algorithms, and that was the section that I didn't record. So we've substantially done what I think needs to be covered together in Zoom for algorithms. And I'm going to suggest that you read through these other sections on your own and then just ask questions next time if there's an issue. And I'm doing that because I don't think there's anything in these other sections that I can add to. I think you can read them, you can follow links, you can explore on your own, pretty straightforward. Algorithms, which I think we still need to talk more about. We did spend some time, we'll probably spend some time today. So that's where we are. We're going to try to sneak in some material from Module 2 to get a little bit ahead, and I'll show you more of that later. So what's due? Algorithm review is due. And at least one person already attempted it, and that's a good thing because I had some comments. And I have time for me to give comments and you to reply before the due date if you get your work done early. Which brings up something else that's really not, I don't think is in the course policy, but let's talk about it. So you submit something, you submit an assignment. I take off points if it's late. And there are some significant issues with what you submitted. I will, or you should feel free to take that and within the 3-week time frame, resubmit it with and resubmit improved code with it. If you can make it better, if you have the time and the ambition to make it better and resubmit it. And I will give you some number of extra points for the resubmission. It's not a one-time offer. You can do that within the 3 weeks as many times as you wish. 2 reasons, of course, to do it. One of you is you're getting more points, and the other is you're taking the assignment as a learning opportunity to do better. So in the purest sense, these assignments are not punitive. They're learning opportunities, and you have the opportunity to rework things and do it better. As we discussed last time, this has absolutely nothing to do with cheating, which is a whole other story. But I've already talked myself out on that, so we're not going back there. So as a reminder, here's your course schedule. And I think that's all I wanted to go through here. Not that there aren't other things in here worth going through, but read them on your own. I can't bring anything else to these sections. Okay. So one more offer on questions while I switch gears here a little bit. Questions?
Yeah. So I sent in an email about the ITN form. So I was wondering if I was in the clear for that, because I didn't get an email back. So
okay, I haven't acknowledged them with emails. The answer is yes, I have it, and I made a note of it.
Okay, thank you.
Okay. All righty. So I want to go back and spend some time reviewing what we did last time for perhaps a couple of reasons, not the least of which is I skimped on some of the recorded material. And let's start with this empty. So the reason that I'm going to write some code for you in class is that I think it's a good opportunity for you to ask questions. And I think I have some opinions, I know I have some opinions in style that differ from what's shown in the class. So that's why we're going to do that. We're going to do that relatively frequently. And one of the first things that I wanted to point out is, unlike what it suggests in the class, there is no reason to write a new project for every assignment. So if you name your main program file main.py, there can only be one of those in a project. If I create a project called ITN160 Spring 2023, I can just create different PY files and go along my merry way. I can also organize these into folders if I need to duplicate some names, which we'll do today. And I want to keep them separate, I'll just put them in their own folders. That also should make it easy for you to think about how to back up this directory. So right over here is the path to the directory for the project that has this name. As you spend more and more time, particularly on your final project, think bad thoughts. Think about what happens if your computer just explodes and you don't have it anymore. This has happened. If you have a backup someplace, then you need to acquire another computer, or you need to go on campus and use the computer lab, but you have a way of recovering your work, particularly with respect to your final project. So what are some possibilities? Some possibilities are take this directory and zip it and email yourself the zip file once a week, once a day, whatever you feel like it. Easy way to do that, select your project, right-click, and say you want to open it in File Explorer. And there is a Windows-looking-ish or a Mac-looking-ish File Explorer. And here's the directory, and you can just zip it from here and do whatever you want. Another possibility is take this directory and write it once a day, because it's easy. Write it once a day onto a USB stick. So these files are just not that big. Any size USB stick you have, you can do it. Maybe you want to create on your USB stick 7 different directories: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and back up your directory into those 7 directories. Just in case something goes really bad, you can always roll back a day. Now, before you ignore what I'm telling you, think about what pain it's going to cause if your computer blows up or you corrupt something. And think about how much time is it worth to you now to keep that from happening. So what's wrong with USB sticks? They're cheap, they have a big capacity. A couple of things that are wrong with them is that occasionally they end up in the wash and they don't do well. When we were doing on-campus classes, occasionally they'd get left in a computer. And because of virus concerns, we were told not to take the USB stick and plug it in and try to find out who it was. So it just went to lost and found. They're not the world's most solidly built devices, and they do break. So unless you want to go for 2 USB sticks, that might be enough to protect you. There's a better solution. There really is. And the better solution, which I don't have time to explore now, but we can explore in the future, is what happens at this VCS thing. We can say, take this whole project and enable version control integration. You can research this on your own. it's going to ask you, what software is there on your computer to do version control? And if you're in Windows, the answer is there is not. I think if you're on a Mac, I think there is. But that's an easy enough to solve problem because the most common software used for version control is called Git, G-I-T, and you can download Git for Windows for free. It needs to be configured with a name and an email address, which I don't think are particularly sacred or checked. And now you have local version control. And what does that mean? That means that all your work is stored by Git, and it knows about versions, and it knows about recovering versions. And it also, in conjunction with PyCharm, will give you color clues over here about what is in Git and up to date, what's not in Git, and what is in Git but is stale. And then there's more things to do. Well, what good does that do you if your computer blows up? And the answer is not much. So the next approach is to go down here and share your project on GitHub. So excuse me, let's take a drink. GitHub is nothing else other than a web-based repository for Gits or Git projects. You need an account. You must verify the account with an email verification or it won't work. And anything that you create that way that you don't pay them for is public. So that's a whole other topic. You can get through it on your own, and we'll try to get through it sometime in the class. So once you share your project on GitHub, it no longer goes through the washing machine. Hopefully it doesn't break. And it will add a whole bunch of icons over here someplace into how to back your work up to GitHub, retrieve it, keep it up to date. Another opportunity for GitHub is if you are working on different computers, you can work on computer A. When you're done, push the work to GitHub. When you work on computer B, pull the latest version down. When you're done, push it back to GitHub. So that's the more professional way. I would say there's some chance, at least in the programming end of it, that if you mention or you use your GitHub account as part of your resume, that it'll be worth something. Another possibility is to create a GitHub account to hold the work that you are most impressed with and use it as a portfolio for job interviews. So who's used GitHub at all? Anybody? No. Okay. It's worth exploring, and it's not that hard. And once you've hooked up a project on GitHub, it's quite easy. Hooking it up the first time is a little squirrely. All right, so let's go through what we did last time. We created 3 templates. They're listed here alphabetically, and I can click on one and more of these things and bring the code up in this window. So let's start with a basic template. And if you remember, we went through the settings and we enabled Control Scroll Wheel as the key to make your code bigger or smaller, which is a wonderful thing. So here's my idea for a basic template. No physical simulator, no GUI 0. Comments started and ended with 3 double quotes. Lines preceded by the bar, which is the shift above the enter key, and includes your name, the class, the date, and what this program is. This number of spaces, because that's what makes PyCharm happy. A main function. So I don't have a main file, but I do have a main function. If I click on that, I can see it show up here and here. And that's one of the beauties of PyCharm, is it will show you where you've used your variables or your functions. The main function just says print hello world because that's what we're supposed to do for our starter program. And then includes this weird looking thing down here. And I don't want to explain it. I just want to say that you can use this as a template and repeat it. And if you do, you'll get this little check mark, this little green arrow over here that will let you, if you click it, run your program or run it in debug mode that we're not ready to talk about yet. So if I do that, a couple of things happens. My program runs down here. It says hello world. And the name of the program that I ran appears up here. So I don't have to come down here. I can use this green arrow to run the program again. So that's my suggestion for a basic template. If you like it, then keep this, build a file just like this and copy this to do work that makes sense with this template. So don't change it for your specific assignment, make a copy. And we'll do that a little later today. Physical simulator. I took the same approach to this and I changed some things from what was posted in the course. I made it simpler for one. I put a heading up here because I'm into that. I've given you the import statements, and we're going to spend a lot of time today in the next class talking about these import statements. They're there because when you hook up PyCharm with a Python interpreter, and I'm hooked up to 3.10, that's located in my, get back here, located in my program files directory. I get certain functions auto-magically, but not all of them. And some of those functions are packaged into libraries that aren't automatically loaded, like time is not a library that's automatically loaded. Why not? Because these things take up some amount of memory and aren't used all the time. So they need to be imported. Other packages or libraries, and I'll use the words interchangeably, are not part of Python. They're third-party external packages, like the physical simulator emulator, or as I say, EMU, PPS EMU. That needs to be imported, but before you can succeed in importing it, it needs to be installed. And that's what D2L talks about doing in a command line with pip, but there are two other ways of doing it. You can come down here, select Python packages, and take a look at what's been installed. And amongst the things that have been installed are PPS EMU, and it brought along with it PPS _ GUI, and a bunch of other things that I've used for different projects. So you can go back here and double check. You can add here, or there's another path through settings to manage these imports. Since I'm here, I'll show you that. File, settings, project, interpreter creates this display, which is a little easier to manage. No, it's not easier to manage. It has more information in it. So this is a place where you can add packages, select a package and uninstall it, do updates, and in general manage things. Well, what is this? This is a GUI front end to pip. So you don't need a command line and you don't need pip directly. You do need pip as part of this project, or else none of this stuff will work. The other advantage of this display is it shows you what's out of date. So matplotlib, for instance, is now available in 3.6.3. I have 3.6.2. That is interesting to me, so I'll hit this little upgrade arrow up here. It will go out and retrieve and upgrade. And of course, I had to pick one that's a relatively big library because I wasn't thinking. And when it reloads it, matplotlib is now up to date. And I could go ahead and do that. Here you see one of the problems with working off of a local interpreter, and that's you end up including a lot of stuff. And some of these things are out of date, and some of them don't work. And that's the advertisement for virtual environments, which the course tells you don't do. And the only reason not to do it has to do with the physical simulator. So what you'll see in your environment will be GUI 0, because that's linked to the physical simulator, PPS, EMU, and PPS GUI. You might not see more than that other than the Python tools, which include pip, packaging, I think, and one other. All right, so that's a little browse through there. So these are imported because I need them for this program. Not every program, this program. So what have I kept here? I've kept my main function, and this is how you define a main function. Keyword DEF, space main, parentheses, colon. How do I know what's in my main function? Well, it's everything that's indented underneath this. So this is my main function. This isn't. Why not? Because it's not indented. Where did I get this nonsense from? I got it from my basic template. So that means the only thing I have to understand now is this stuff. But anytime you use the physical simulator, this is what this is what you need to do. Oops, sorry. This is what you need to do, and here's an example of what you might do. So I need to establish a connection between Python and the physical simulator, and this is the way I do it. And this is very, very important. It's the little equal sign over here. That is not a statement of equality. Repeat, it is not a statement of equality. It is not symmetric. You can't flip the left and right sides around and expect it to work. So we have to do, when we see an assignment, which is what equals is, we're going to assign a value. Well, how are we going to do that? We're going to look at the right side of the equal sign, and we're going to do whatever it says to do. In this case, it says go to the PPS_EMU module and use a section of code called sensor with a capital S. And the way in which we're using it forces us to use parentheses. The result is to establish an object that hooks us up to the physical simulator. What do I do with that object? I assign it to the variable sensor on the left. So whether it's A equals 7, which assigns the value 7 to A, or an input statement, which we'll look at later, or creating objects like this, it's always the same. Check out the right side, do whatever you need to do, follow the hierarchy of operations, deal with parentheses, call things, and then when you're done, plug the result into the variable or variables on the left. PyCharm is going to help you, because if I click on sensor, I'll notice it comes up in kind of a dark red. And here it comes up in kind of a light green. That's because it's defined here and it's used there. So that's how you find spelling errors. And that's how you see where this thing has been defined and used. Nothing is sacred about the name sensor. You could have called it Betty and it would still work. The right side would be the same, but every place sensor appears in the program, we're going to use Betty instead. Why not? Why don't you do that? Because who knows what that means. As we'll see today when we talk about these things a little more, writing programs, naming a variable is an opportunity to make your program easy to understand. All right, now that we have sensor, which is an object, we can do sensor dot lots of things. As a matter of fact, if I go here and I type sensor dot, a list will come up of those things that I can do with sensors. Another list here has to do with objects in general. So this is some self-documentation and some help from Python. The only thing I want to do right now is sensor.output. Okay. Well, how does that work? I hover over it and it says sensor.output can use three things in the parentheses. The first one is not required and only has to do with object-oriented programming. The device must be provided. I must tell it what device am I outputting to. And the value you probably want to specify, because how do you know what you're doing with the output to the device if you don't have a value? So what does line 15 say? It says this sensor object that you created on line 13, you want to do an output function. How do I know it's a function? It has parentheses. Where is this function? This function is within the PPS_emu code. What do I want to do? I want to turn the red LED on. How do I know that? I know that because there's a cheat sheet in D2L that we will look at. Again, we looked at it once already. Then what I want to do, I want to go to sleep for 2 seconds. Do not use this in a GUI 0 program. Use this in GUI 0 programs. Because of the way the GUI 0 programs work, sleep statements mess them up. And if you need to learn this the hard way, go ahead and do it. The sleep statements will mess up GUI 0 programs. How do I know? Well, I know because the first version of PPS_GUI used sleep statements and the program didn't work worth you know what. When it was rewritten by Chuck and that came out of there, the program started working a lot better. So turn the red LED on, wait 2 seconds, turn the red LED off. If this program runs, you know that you've got the physical simulator up and running. Well, I don't right now, do I? There's no physical simulator here. So the instructions in D2L tell you to go to the command line and start it. No need. You can go down here to where it says terminal and type PPS_, not dash, _GUI. And if things are the way they're supposed to be, then you'll get a message from Pygame that it started. And then you'll get a GUI window show up that is the physical simulator. Now that this is running, I can come over here and I can run this program. The red light comes on, the red light goes off, the program terminates. So your first several, after the initial assignment or two that are going to be more basic based, we're going to get into simulator programming, and those programs you're best off starting with a copy of this template. Essentially, the template is in there in D2L, but it's fancier and doesn't have my style of doing things. All righty, one more. Those of you who had said to me, can't we get started with GUI 0 early? And the answer is yes, but some of it you're going to end up exploring on your own, and some of that we're going to sneak in. So the simulator goes away. It's kind of stuck up there someplace. Or maybe the simulator doesn't go away because there it goes. Notice the imports are different here. I don't import time because it's an evil thing to do. I told you don't do it, so don't do it. And I import GUI 0, but I do it in a slightly different way. We'll talk a bunch about that today and next time. Instead of saying import GUI 0, I say from GUI 0, import everything in the library. And I can do that because it's not a very big library. It's not a significant load in memory to import everything. And that means, compare this, PPSEMU.sensor. Here, I can just say APP. Although it comes from the GUI 0 library, because I wrote my import this way, I just need the name of the module. How do I know it's from GUI 0? I hover over it and it tells me that it comes out of the GUI 0 library. It also tells me what the defaults are. The default title is GUI 0. The default width is 500 pixels. Height is 500 pixels, and another few things. Okay, it's an assignment. What do? I evaluate the right side of the equals. It generates an object. It turns out that it's an object of type capital APP with defaults. What does it do to that object? It assigns it the variable APP, which could have been called Betty, but that would confuse people. So in general, I'll call it APP. Where is it used? It's used over here and it's used over here. Well, let's do the second one first. app.display is 100% critical in successful GUI 0 programs. It keeps the window open. It keeps the program alive. And as we'll find out when we get into it, it also listens for events happening in the GUI environment that we created, of which this is not an example. There are no events in this program. So what's the simplest thing we can do? Well, we can create a text widget or object. We must tell it where to put the object, and the only place to put it's an APP. And if we're creating text, then we need to set a parameter for the text and tell it what text to put in the object, and it's hello world. So when we run this, what do we see? We see a window. The window decorations are appropriate to your operating system. Actually, the truth is they're appropriate to your window manager, which is the same unless you're in a Linux environment. So they will look like either Windows, Mac OS, or Linux, where you could be running different window managers. And in this window, which is 500 by 500, there's a default title of GUI 0. There's a default color background of light gray. And there's a text widget that says hello world. And that text widget is in the, as far up as it can be in the window, and horizontally centered, which is the default. If I don't like that, there are 4 ways of putting the widget in there. There's top, bottom, left, and right. We'll explore those later. Okay, so the name of my APP widget is APP or Betty. What's the name of my text widget? And be careful, it's a trick question. And I think we discussed it last time. All right, $5.
Right. They're
Well, hold on,
technically
I got to turn up my volume. Say again?
there technically isn't a name for it.
Yeah, there actually is no name for it because there's no equal sign. And we call those anonymous widgets.
Anonymous widgets. Okay.
So there is no need to name a widget unless there's a need to name the widget. Duh.
Right.
And why don't I need to name it? I don't need to name it because I'm never going to change it and I'm never going to ask for its properties.
Okay.
So APP, I need it because I need to use it here. Text, no. I would strongly suggest you don't clutter your code by naming widgets that don't need code, that don't need to be named. If you do, you would call this, if you follow my convention, something like txt_greet equals, and PyCharm says, what are you doing? You created a local variable, but you never used it. Can I help you by removing that target? Sure. And notice also right now I have a 1 warning over here. And if I click, I'll kind of get the same message. So if I hover and say remove the target, then it goes back and I get my green check mark. As I believe we learned last time, if the check mark is green, your code is clean. So keep your eye on what's going on over here. And if 50 lines of code have 30 warnings associated with them, you need to pay attention. If you can keep the check mark green within reason, like maybe I named it and I'm going to use it later, that's okay. But if you've got everything you need to have in your program and you still have warnings, take a look and see what you can do about them. So that's the 3 templates. I was going to see if I could post these templates into D2L. I haven't done that yet. It should be easy enough to do, just haven't had a chance. So these are the starters. These are not bad starting points. Nothing GUI, physical simulator GUI, and GUI 0 GUI. So as starting points, there's nothing that won't fit into these templates that we're going to do in the class. There are opportunities to end up with a lot of code inside main. At some point, you need to say, this is getting too long, and the code needs to be broken up into new functions. Or in GUI 0, you're going to say, I need an event handler. Well, what is an event handler? It's a function. So I need to build the function. Then we have to name the function. We got to put it someplace. We may have to import, as we'll see in our examples. All righty. So before our break, let's go back and look at something else in here, and that is course resources. Here's a thing in here that says valuable course documents and resources. Now you got to think, if Chuck named it that you need to pay attention to what's in here. He didn't do it for his own health. He did it to give you some valuable resources. Well, here is a Python cheat sheet. Very, very valuable on basic Python. 2 pages, so 8.5 by 11, front and back. Almost everything you need to know about Python. Here's the cheat sheet for the physical simulator. If we go in here, this is, I think, 3 pages long and has all of the names, the values, and some sample code. So that's where you go for that. And lastly, and I ignored it until I looked at it this morning, if you go here, free book, yay, free book. Create graphical user interfaces with Python, but it uses GUI 0. Not only does it use GUI 0, but it gets you into the GUI 0 tutorial. This is where you go to learn about GUI 0. Everything I learned about GUI 0, I learned in this website. You want to know about widgets? Here are all of the widgets. There's not that many of them. You want some topics that don't fit directly into widgets? Here they are. You want the book? You can get it for free. In the book, there are 10 fun GUI 0 projects. They're very game-oriented and kid-oriented, but they're completely worked out projects. As you might guess, these projects are not available for your final project, right? Should be obvious. You could use it for an inspiration, but you can't use it for your final project. So don't ignore a section called Valuable Course Documents and Resources. It's there for a reason. All righty. So I'm going to say it's break time, and I'm going to say we're going to get back from the break at 10. So, and I have resumed recording, so take that off of your list of things to worry about. I'm going to spend the rest of the time looking through the first two modules, the first two numbered modules, D2L. Module 1 is, as you might guess, fairly introductory. We've talked about algorithms. I'll talk a little bit more about them in a moment, but I would like you to read, not glance, but read these lessons before the next class and ask me any questions. I don't think there's anything I can add to those lessons that would be valuable. So you read them, ask questions. Algorithms we discussed last time, and of course there's an algorithm review discussion topic here. I can't stress more, or I can't stress enough, the importance of thinking about an algorithm before you start writing the program and executing your thoughts in code. Without that planning, you tend to have things that don't get into your understanding, they don't get into your code doesn't reflect your planning. And as I showed you last time, you can end up with something that looks like this. So you think you have a posse, or a program. What you really have is a pile of men and horses and guns, or just a pile of Python code. So your code has to tell a story. It has to follow a plan. And aside from the most trivial programs, there is no program that's going to work properly and work well without a plan. Now, that doesn't mean that you won't have some Python language issues or some simulator issues or some GUI 0 issues, but it does mean that there's a plan. And the next part of that plan is dividing your program up into functions. So don't ignore the lesson and don't ignore the exercise that we're asking you to do for the review in its importance. These are critically important concepts. The bigger the program gets, the more important they are. So if we look at module 2, there's some interesting things here. The first thing we see here that's interesting we haven't seen before are 2 practice exercises and also a lesson called creating a first program. This is where we either give you code itself or show you the code in a little YouTube video. This is your code. Using this code, the code that we give you is not cheating. It's using the code that we give you. And let me state the obvious. Your assignment has to do with Fahrenheit and Celsius conversions. If we show you how to do feet to miles and miles to feet here, how to do kilograms to pounds and pounds to kilograms there, and this is kind of a slightly more sophisticated thing with distances, these are supposed to give you a big hint as to how to do assignment 3. So people who don't like spending time in course material, look at assignment 3 and start at the beginning. People who want to make use of the course material, ask yourself the question, what do these practice programs that have solutions have to do with the assignment? And the answer is plenty. That's why they were designed. So if we go to this one and we go down here and we look up code, we find completed code written in Chuck style, spread over 2 files, a main.py, a convert.py. It does what it's supposed to do. He provided a description here, an overly wordy description. He loves inline comments. I don't. He also, well, with respect to something like main, explains Python, which I don't think is necessary. I think code is supposed to explain your the logic of your code, not explain how Python works. Here he's got this comment in kind of a strange place. Number one, I don't like inline comments. I would have put them above. And number two, there's an official way of commenting functions. Part of what I'm trying to teach in this class is good programming practices and good Python programming practices. And I'll show you when we get there a good practice for documenting and commenting programs. So this is code that we're giving you. Here's a video that goes along with the code. Don't ignore it. It's there for you to use. So what we'll do for the rest of the class is, I think what we'll do today is we'll try to do the lesson and the first practice, and that's probably going to be enough. Next time we will do the second practice. So by the next class, you should have read the lesson, because I can read it the same way you read it. We will have worked through the first and the second program. So let's take a look at what this program is asking us to do. And I'm just going to talk to you about it because I'm not going to play the video, but we're going to do it in a minute. In short, what's going on here is that you need to write a program that converts feet to miles and miles to feet. Can't get much simpler than that. If you're going to convert miles to feet, then you better give the program the number in miles and expect it to return the number of feet, and vice versa. So that's the goal. The goal is to provide these as functions and in a separate file. Well, we don't have to start out with them in a separate file, but we will move them to their own file. I guess I'm going to need to do a little pre-planning here, since all of these are written to put these things into a file called convert.py. And that's not the worst name for programs, for a program that has conversions in it. And we're going to write multiple assignments in the same project, then these things better be put into their own folder. So let's plan on doing that. And I think I made enough notes that I can come over here and do it. So I have a plan. I'm going to create a folder. Right-click and say new. The simplest thing to do is say directory. I want a new directory. I could also say I want a new Python package and pretty much end up in the same place. But this is more, has a little less frills to go with it. So I have to name the directory. And since this was called in Python, in D2L rather, first program, let's call it first program. So here's my directory. Now I want to make the decision, what is this going to look like? Well, it's not a GUI. It's not GUI 0. It's not a simulator. So it's going to look like the basic template. So I'm going to come over here to my basic template, right-click, and say copy. Then I'm going to select the work folder that I'm in. I'm going to right-click and say paste. And it says, do you want to rename it? Yeah. And I'll actually give Chuck his wish. And I'm going to name this file main.py, because other files named that will be in separate folders. So I can do that. And here I have a checkbox that says open in editor. So I'll do that. Now, obviously, the point of writing comments is to have them comment your code, not just be there. Although I will say that comments are in our rubric. So you will lose points if you don't have comments. You'll lose points if your comments don't reflect your program. And you will probably lose 1 point if you misspell your name, but only one student has done that. On the other hand, if you submit a program with someone else's name in the comments, you're in big trouble. And one person has done that. So remember to look at the comments. So what is this? This is a program to convert between miles and feet. So the print statement has no part of it. Everything else, which is very little else, is valid, and we can start working. Notice that I have an error on line 13, and the error is because my function has no lines in it, and that's not legit. A function has to have at least one line, and if I'm not ready to write it yet, I can just put the word pass in there, and PyCharm will give me a pass. It will let me think that this is a good program. So where we're going with this is that we want to do these conversions in functions. And I want to turn on my fan because my room gets hot. So we're going to start this the easy way, and then we're going to do what the assignment says, which is to put our conversion functions into a separate file. So if I want some conversion functions, I need DEF to define them. And here's a point where I diverge from Chuck. Chuck named his function, I think, M2F. And that's a cute way of saying miles to feet. Yeah, it's cute, but not every, get it, miles to feet. Not everybody knows that or would pick that up immediately. So I'm going to suggest when you create a function, give it a name that basically anybody could figure out. Like, how about miles to feet? You think anybody could figure out what that function is there for. In the parentheses, we have to say, what are we going to give this function? Well, we're going to give it a number representing miles. This is a function, so it ends in a, the definition ends in a colon. And PyCharm gives you an indentation. I'm not ready to write the function yet. I can just type pass. And now I can define another function called feet to miles. Feel free to interrupt me if I've done something either dumb or something that you don't accept. Just let me know and we'll go back. It's much better to talk about that when it starts to bother you. So PyCharm says, I have some concerns about your code. And if we pull this up over here, it's a lot of PEP 8 stuff. Now I can one by one go through here and correct it. I could click on any, hover on any line with a yellow squiggly and get a suggestion to reformat the file. And if I do that, PyCharm spaces it out the way it likes to. And you can see that what Python likes to do is put 2 spaces between functions. Actually, before and after. Okay, so this is our introduction to functions. Functions are like factories. They take things in, they might take things in, they do stuff, and they might return stuff from the function. So raw materials come in, they get processed, finished goods go out. That's a factory. So what comes into this function? Well, a numeric value for miles. And what comes out, we mark with a return statement. So return means give this back. How would you suggest we convert miles to feet, since that's our goal?
So converting miles to feet, it would be x equal or x2. You have one variable that is the number of miles that you have up there. And you have another variable which would be equal to 5,280 of the first value.
Okay, you sold me, except you called 5,280 a variable. I'm going to call it a literal.
Okay.
Yeah, you have a choice. And the other example took the other approach. You could create a variable, set it equal to 5,280, or you can just put it in there as a literal. One cute thing that you can do is if you want to simulate a comma in the number, you can use an underscore. But that's just cute. That's not necessary. And notice now everything here, nothing here is gray anymore. So miles comes in over here. It's used over here. What gets returned is an expression, the expression of whatever came in times 5,280. All right, that was so much fun. Let's do it again. We're going to turn feet. And what? What's our math?
It would be, I'm not sure. It would be divided by 5,280.
Right. And I guess the underscore is bothering me, so I'll take it out. For numbers in the millions, maybe. So I now believe that I have my conversion functions. To the best of my knowledge, maybe with a little help from Google, I have my conversion functions. What I don't have is I don't have anything in my main, and I've never used these functions. So it's actually interesting that they come up in yellow, not in a pale color. Not sure why that is, but anyway. And I'm going to make this program a little bit different than the one that's in D2L, but the essence is the same. If I want to convert miles to feet, and I don't want to hard code the number of miles, that means I want to get some information from the user. And let's see how we do that. I'm going to change this in a little bit, but I want to make a point. So I'm going to create a new variable called input underscore 1. And that's on the left of my statement. And I want to use a new function that we haven't used before called input, which is a standard Python built-in function, no imports necessary. And input takes a prompt optionally, but we might as well tell the user enter number of miles to convert to feet. And here's just a styling thing on my part. I like to put a colon and a space at the end of the prompt so the cursor ends up at some reasonable place. Okay, so now that I've done that, I could create another variable called return underscore 1. And that's going to equal miles to feet. Now, all I have to do is type the letter M and watch PyCharm come up with things that have the letter M in, including my function. Okay, critical point. PyCharm says you should give me miles. What do you suggest that I type in the parentheses?
Feet.
Says, I don't know what you're talking about. Got a red line here. Factory. It's a factory. What's going to go into the miles to feet factory?
They've got to put miles in.
Miles. It's going to go into the factory. I don't know what you're talking about. Well, you should. I said miles up here, didn't I? Miles over here, it says, is unknown. And now we need to learn about one of the more annoying things about programming that you need to reconcile very quickly. And that is that variables are defined only within the function where they're initially created. So miles over here is unknown. Miles up here is known just fine. So I need another guess. You guys are 0 for 2. Third one's the charm. What should I put in there? What variables exist within the function that I'm working in? I see only 2 of them. How do variables come into existence? They're on the left side of an equal sign.
So you have to input 1 into there.
Yeah, and if I just type IN, it says, hey, I see a variable input underscore 1. Do you want that? Sure. So I'll just double click it. And now this turns color and it goes in over here. So I'm saying whatever the person inputs, that value is going into input underscore 1. That value over here is now the input to my function. The answer comes back here, and that's gray because I've never used it. So I'm going to just do something simple and then come back and do fancy later. Input 1, comma, return 1. Okay. So just looking at miles to feet, questions. So looking at what I've written here and looking at this function here, ignoring feet to miles, ask me some questions if you have them. And this means one of 2 things. Everybody understands, or no one understands, or people are too shy to ask questions.
So I tried running it as it's written right now, and it not pleasant.
Okay, that's an observation, but I'll take it. So let's run the program. Oops, I run it twice. Enter the number of miles to convert to feet. 2 miles. And
Okay, it's not just me.
right. Well, that's pretty bizarre, isn't it? Now, notice the program didn't crash. If it crashed, you'd see stuff in the light red or reddish orangish color. But we sure didn't get anything that we liked. I'll give you a hint. What we have over here is 5,280 copies of the string 2. Because what comes out of an input is a string, whether it is or isn't. Input always gives you a string. And I've got a decision to make. I need a number. And my decision is that number going to be an integer or am I going to allow decimal values? Chuck used integer. I think I'd prefer to call it a float. So float says, take the string that comes out of this and run it through the float function, which is a standard Python function, and create a floating point number out of that function. Hover over this, and it will tell me that input underscore 1 is of type float. So it's all good, or better. So now I can use the arrow up here. Number of miles convert to feet. I take 2, and it's 10,560. That smells good, right? That's right. But I also now have the possibility of saying 1.5. And that works. So why not allow somebody to type a floating point number? Right? Why not? All right, so let's ask again. Now I have something that seems to work. What questions do you have? Notice.
I'm sorry.
Go
I
ahead.
just kind of lost part of the float input part. The thing that usually did last.
I'm sorry, your voice is a little broken up. Try again.
I said I got kind of lost on the float input part, the last thing that you did.
Okay, that's fair. So we know from algebra that when we evaluate something, we have to go from inner parentheses to outer parentheses. So the first thing that happens is this. We get the input and, well, we put out a prompt, enter number of miles to convert to feet. Then we get the input from the user. The input is a string, whether it looks like a number or not, it's a string. So then we do the second parentheses, and float is a standard Python built-in command that says, take a string and convert it to a floating point number. Does that make more sense?
So the float command is basically telling it to take the miles and convert it to feet.
It says take the user input. It doesn't
Okay.
know from miles to, no, it's not converting it.
Yeah, it's just what we're like using, like.
Yeah, it's taking miles that was entered as a
So if
string.
I'm not mistaken, without the float command in there, it's reading it as a string.
Yeah, it's treating it as a string, and when you multiply a string by a number, it makes copies of the string, which is why we saw all of those twos. So on line 18, we don't know what that number is. We don't know what it represents. The clue is in the prompt. Enter the number of miles. The next clue isn't until the next line. And then after that, we have results. So within the function, we're executing this thing from top to bottom because there's nothing in here to say to do it differently. So 3 steps. Get your, well, 3.5 steps. Get your input and convert it to a float. And there's nothing wrong with doing this, especially when we start doing it. Put in a comment, convert user input to a float.
1401 at the moment. Newport Cat Pike, mild unit. Oh, yeah? 280 or 198? Charlie 198. I got there.
Ben,
Right
Ben, you
before
need to
they-
mute,
they-
Ben, mute, Ben,
So you work for my brother.
Ben, mute.
There he goes.
Thank you. Convert. Float input to miles. Print the result. Okay, so now I've used spaces and comments to kind of break up the code, maybe make it a little more readable and a little more obvious what's going on. The print statement's pretty darn ugly, but we can deal with that. So questions on what's going on here or what that has to do with this function. So I can click on this and I'll get a color match up here. This is where it's defined. This is where it's used. Does it require a value? It does. You can't leave that out. Does it matter what that value's name is? The answer is no. I could have called it miles, but I didn't want you to think that it was the same thing. So I called it input _1. I could have called it Sally, but that would be confusing. Why am I calling, the floated value of the user input Sally? I'd rather call it input _1. How we doing? Questions? So except for style differences, this is what you have in D2L. So I'm not inventing anything new. And the fact I chose to make this a float instead. Okay. if there are no questions right now, I've got this other function that I haven't used. Well, that sounds way easy, not much thinking. Why don't I just take this code here and copy it and paste it over here and change this to a 2, change this to a 2, change this to a 2, change these to 2, change this prompt, convert number of feet, enter number of feet to convert to miles. And most importantly, don't run this function. Convert float input to feet. I've got the wrong function here. It's not miles to feet. It's feet to miles, to which I'm going to pass whatever was entered there after having floated it. So let's see what happens now. So we had 1.5 miles converted to 7920 feet. 5,000 feet converts to 0.94 blah, 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 blah miles. And that's about right because I'm a little under 5280. Again, not so pretty. And probably I want to skip a line between these two. So any questions about why to do this? I just copied this and just changed what I needed to change. Essentially the same code. Now I've used both my functions. Okay. Questions? This needs to make perfect sense to you if you're going to work on the assignment on your own. Trust me, it only is going to get worse from here. And there are no such things as a silly question. Okay. So I'm not done. And the reason I'm not done is that in the assignments, they want these functions to be in their own file. We'll talk about why in a minute. So first program now has main.py. I want to create a new Python file in here called convert.py. And notice it goes in the proper place in the hierarchy. And I want to pull these functions out and put them in here. And PyCharm says, I'm not happy. Well, if I hover over it, it says, I want to see a new line at the end of the file. Reformat it, sure, I can do that. And now there's an empty line at the end of the file. I have a green check mark. It's all good, except what's going on here? Well, one is the spacing is wrong. So let's reformat. And now we can see that clearly it doesn't know what these functions are. Why not? Because it can't find them. Anybody want to go out on a limb and suggest at least the command that we use to find them?
Import?
Good guess. Because import tells us to import things that that we don't have access to without importing. Now it gets tricky. What we need to import is just convert. You leave out the PY. And it says, I don't know what you're talking about. So we haven't made progress yet. But what we need to do if we're going this road is we need to qualify the name of the function with the name of the module that it's in, which happens to be convert. So if we say convert dot, it says, oh, look what I found. And it's already there. So we don't have to do anything. So if I have a separate file and I import it, then convert dot will show me what's available in that file. Just remember that the file has to be in the same folder as the main, or else you have to tell it where it is, and to leave out the .py. So if we run this again, we hope that nothing's changed. So 1 mile is 5280, 5280 is 1 mile. Questions? And this is the model for the practices and also for the assignment, is to create a convert.py file. And if you put them in separate folders, then each folder can have its own convert.py and main.py. Questions? Cool. Does this look kind of clunky over here? Convert dot. It's getting kind of long, and it's getting long partly because now the parrot wants to contribute. Okay. Stupid bird. A little clunky. So I have some choices. I can do what I did with GUI 0. Well, what did I do with GUI 0? From GUI 0, import everything. Let's try it. From convert, import everything. And now, just like in GUI 0, I could do that and get away with it. Run it. 1 converts to 5280, 5280 converts to 1. So that's another way of doing it. I'm not really concerned about memory utilization. So this is probably the easiest way to do it. There's another way that I'll show you that there's no real reason to use it here, but it's this. So if I say from convert import M, it says, well, based on convert.py, here's something you might be interested in, and I am. And then if I say F, it says, here's something you might be interested in, and I am. So you can explicitly say what you want to import, or if it's a very small file and you don't care, you can import asterisk, or you can import convert and then have to fully qualify the names over here. So if you're importing all of your modules, then you just need the name of the function. You don't need to qualify it. All right. Is anybody either excited or asleep? One or the other.
I'm excited.
Okay, cool. That's one. Of course, we could have people unmute and see if we hear any snoring. So while we're here, and we're not going to get too much farther in today's thing, we'll be able to finish this up. Let's talk about the official way of documenting functions. And it's not to use the pound sign, either above or below the name of the function, or in line, which I really don't like. It's to use 3 double quotes, 1, 2, 3. And PyCharm says, I know what you're doing. I'm going to give you 3 more triple double quotes, 3 more double quotes. And if you know the game being played, you want to hit enter right here. And watch this, magic happens. It says, I know what you're doing. You are providing miles as a parameter, which means the thing in parentheses, and you are returning something, but I don't know what it is you're returning. Well, I do. I'm returning feet. I'm returning miles converted to feet. Oh, no, actually, I'm just going to say I'm returning feet like that. Then I'm supposed to come up here and I'm supposed to provide my documentation. And I'll give you a hint. Inside the 3 double quotes, there's some formatting magic going on. And if I want a multi-line comment, I need to separate them. I need to start each line with a vertical bar and a space. And now I can write whatever comment I want. And that really, there is only one line. Convert miles to feet. And okay, I'll get carried away with it by multiplying input by 5280. Okay. So that's the recommendation. The recommendation is to use this thing, which is called a doc string. And doc strings are built with 3 double quotes. One of the few cases where it matters if you use a single or double quote. This is something you have to do with double quotes. It will tell you what parameters are here. And we could add more information, floating point, floating value, return, we want to say something. And this is, this is professional documentation for functions. Now, this is magic. It works by magic, miles to feet. I'm going to come over here and I'm going to hover over miles to feet. And you should go, oh, look what happened. It popped an information window. And in the information window, it says convert miles to feet by multiplying input by 5280. The parameters are miles, it's a floating point value, and it returns feet. Now that's magic, right? That's why this works. Go over here and hover over APP, and it goes into the GUI 0 library and finds this information, but it also finds this text. So you can make your own pop-up documentation work by knowing this trick. So I had so much fun doing it there. We'll do the same thing over here. It's going to return miles. Oh, I got it screwed up a little bit there. The parameter is feet. If I would have let it do it, it would have done it better. And you'd have to read more about the formatting conventions to understand all the options you have. Providing input by 5280. And of course, since this is basically comment, it doesn't change the way the program works. It just provides documentation. Now, here we've kind of documented what the whole thing does. There's probably not a good reason to put a doc string under here. All right. So there are a bunch of critical concepts in this pretty small program. My program is probably almost 50% blank lines for readability. Questions? Sip of seltzer. Okay. Review. Since we're spread over 2 files and we might reuse these names, create a new directory. Just go up here, right click and say, I want a new directory. In that directory, if you want to name your main file main.py, fine. You want to name it something else, fine. Convert.py, I don't care. You can name it whatever you want. Convert.py is not a bad idea. When you submit this to D2L, you must submit both files. So you're going to have to include these files separately. And there's I don't remember if it's a paper clip probably, or a button that says attach or something like that. In the main, we are going to get user input here and here. The input includes a prompt. And since the input always comes back as a string, we use the word float to get it into a form that we want. Now that it's in the form that we want, we use it as input into our function. The return value of the function is over here. The print statement is ugly, but we can worry about that another time. And if it works for miles to feet, it's going to work the same way for feet to miles. We import everything from convert.py. Convert.py just has two functions. The doc string is bigger than the whole function. And we know, get our math straight, and it's all good. Except there's a problem. And it turns out to be a big problem. Turns out it's a problem we can't solve today. Number of miles to convert to feet. Frog. Who can convert frog from miles to feet? Anybody?
I don't think you can.
Yeah, well, neither does Python. So when you do that, this is Python talking, not PyCharm, it's Python talking. Python says these things are called exception errors, and they're best read from the bottom up. It says, you have gotten, or Python says, I have gotten a value error. I could not convert the string to a float. The string that you gave me was frog. Here's the line where it happened. This is the code itself. It happened on line 13. Yes, it did. And line 13 was called by line 32. Yes, it was. But at this point, I've lost interest. The important thing here is the value error and line 13. And this is a real problem, right? Because we've asked the user to enter the number of miles, and they've typed something that Python can't deal with and presented the error in a manner that would not make somebody happy. So what we will learn later on is that since these are called, or the right way of describing this is Python threw an exception. And what kind of exception? A value error. And what can we do about it? We can catch the exception. And in Java, it's try catch. In Python, it's going to be try except, EXCEPT. Once we learn about try except, we can deal with the exception and we can do something friendlier than this. So we will see that later on. But basically, you get there by looking at this and saying, this is a point of vulnerability. Here's a place that my program could crash. What should I do about it? Well, I should protect it. And we'll learn how to do that. Okay, so next time, we're going to do the practice, which is kilograms to pounds. If you think you can do kilograms to pounds, that means you can do pounds to kilograms. And that means you can also think about how to do the assignment, which is Fahrenheit to centigrade or centigrade to Fahrenheit. So you really have enough information that you could probably tackle the assignment that goes with this, especially if you believe that you should start working things ahead of time. So if we go back here and look at the assignment, this should be readable to you. And, you know, if you're ambitious, then read this before the next class and ask me questions. Now, he uses this F to C and C to F, and I don't like that. I would spell it out. The only problem with that is you need to figure out how to spell Fahrenheit. But, oh, actually, it's spelled over here. The other thing we'll do next time is we'll get a prettier output. All righty, it is exactly that time. So I am going to stop the recording.